Is math a fundamental part of the universe, a cosmic language waiting to be discovered? Or is it merely a human invention, a set of tools we created to make sense of the world around us? This question has puzzled philosophers, mathematicians, and scientists for centuries. It's a journey into the very nature of reality itself. On one hand, you have the Platonists, who believe that mathematical concepts exist independently of human thought. They argue that numbers, shapes, and theorems are real. It's abstract objects that we discover, much like an astronomer discovers a new planet. The universe, in this view, is inherently mathematical. Then there's the opposing view, often called formalism or anti-realism. This perspective suggests that math is a product of the human mind. We invent the rules, the axioms, and the symbols, creating a powerful and consistent language to describe patterns we observe. Math, in this sense, isn't out there in the cosmos. It's in here, in our collective consciousness. So which is it? Cosmic truth or a human creation? To explore this, let's look at one of the most intriguing and mysterious mathematical phenomena: the Golden Ratio. The Golden Ratio, often represented by the Greek letter phi, is an irrational number approximately equal to 1.618. It's found when you divide a line into two parts, so that the ratio of the whole line to the longer part is the same as the ratio of the longer part to the shorter part. This might sound like an abstract geometric exercise, but this exact proportion appears with uncanny frequency throughout the natural world. Consider the spiral arrangement of seeds in a sunflower head. The number of spirals going clockwise and the number going counterclockwise are almost always consecutive Fibonacci numbers, which are intrinsically linked to the Golden Ratio. Similarly, the elegant spiral of a nautilus shell grows in a logarithmic spiral that perfectly aligns with the proportions of the Golden Ratio. You can see it in the branching of trees, the veins in a leaf, and the spiral patterns of pine cones. Even the proportions of the human body are said to exhibit the Golden Ratio, from the distance between our fingertips and our elbow to the structure of our facial features. This widespread presence of the Golden Ratio in nature is a powerful argument for the Platonist view. How could a mere human invention be so deeply embedded in the fabric of the biological world? It suggests that this mathematical principle exists independently of us, a fundamental building block of life and form. It's as if the universe has a preference for this specific proportion, using it to build things in the most efficient and elegant way possible. If nature itself is using math, then it seems we are simply uncovering the blueprints it has been using all along. We didn't invent the Golden Ratio, we noticed it. But the story doesn't end there. Let's look closer at the connection between the Golden Ratio and another famous mathematical concept, the Fibonacci sequence. The Fibonacci sequence is a simple series of numbers where each number is the sum of the two preceding ones. It starts with 0 and 1, then goes 1, 2, 3, 5, 8, 13, 21, and so on, stretching into infinity. What's fascinating is what happens when you take any two successive Fibonacci numbers and divide the larger one by the smaller one. As you go further and further down the sequence, the result gets closer and closer to the Golden Ratio, 1.618. This intimate relationship between a simple additive sequence and this fundamental ratio of proportion is, for many, another piece of evidence that math is a discovered truth. The Fibonacci sequence, just like the Golden Ratio, also appears everywhere in nature. The number of petals on many flowers is often a Fibonacci number. Lilies have 3 petals, buttercups have 5, delphiniums have 8, and daisies often have 34, 55, or 89. This isn't a coincidence. Plants grow from a central point, and as they sprout new leaves, petals, or branches, they do so in a way that maximizes their exposure to sunlight and air. The most efficient way to arrange these new growths without them overlapping and blocking each other is by rotating each new part by an angle. Related to the Golden Ratio, this process naturally generates the Fibonacci numbers and the spirals we see. So are plants consciously performing calculations? Of course not. Instead, it seems that the laws of physics and biology, driven by efficiency and survival, naturally converge on these mathematical patterns. This leads us to a profound conclusion. Math might be the language that describes the most efficient and stable way for things to exist and grow in our universe. From this perspective, our role as humans has been to recognize these patterns, give them names like Golden Ratio and Fibonacci sequence, and build a formal system around them. But let's play devil's advocate for a moment. and consider the anti-realist argument. Could it be that we are just seeing what we want to see? The human brain is an extraordinary pattern recognition machine. We are hardwired to find order in chaos, to connect dots, and to create meaning. Perhaps we are simply projecting our own invented mathematical framework onto the world. We created the concept of numbers, ratios, and sequences. And now we see them everywhere because that's the lens through which we've taught ourselves to view reality. Is the Nautilus shell truly a perfect golden spiral? Or is it just close enough for our pattern-seeking brains to make the connection? Are we cherry-picking examples in nature that fit our mathematical models while ignoring the countless instances that don't? For instance, while many flowers have Fibonacci numbers of petals, many others do not. The universe is a messy and chaotic place, and perhaps our clean, elegant mathematics is just a convenient oversimplification. The core of the formalist argument is that math begins with axioms, fundamental assumptions that we accept as true without proof. For example, a straight line can be drawn between any 2 points. From these self-evident truths, we logically derive all the complex theorems and proofs that make up mathematics. If the foundational axioms are our invention, then everything that follows must also be an invention. We chose the rules of the game. The fact that the game we invented happens to be incredibly useful for describing the universe is a happy coincidence. But it doesn't mean the game itself exists outside our minds. Think about it this way. We invented the rules of chess. The game is logical and consistent. But no one would argue that the concept of a checkmate or a knight exists as a fundamental truth of the universe. There are concepts that exist only within the system we created. Could math be the same? A grand, elaborate game that we invented? One that just happens to mirror the behavior of the physical world with astonishing accuracy? This brings us to a middle ground, a synthesis of the two opposing views. Perhaps math is both discovered and invented. The patterns themselves, the ratios, the symmetries, the physical laws are inherent to the universe. They exist independently of us. They are the discovered part. However, the language we use to describe these patterns, the symbols, the axioms, the formal systems of logic, is our own creation. That is the invented part. The universe doesn't operate on the symbol pi or the equation E=mc. These are human-made labels and descriptions. But the underlying realities, they represent the constant ratio of a circle's circumference to its diameter. The equivalents of mass and energy are real and discoverable properties of our cosmos. We don't invent the law of gravity, but we do invent the mathematical equations that describe it. We are like cartographers, mapping an unknown continent. The continent is real and exists whether we map it or not. But the map itself, the lines, the symbols, the names we give to mountains and rivers, is our invention. The map isn't the territory, but it's an incredibly useful representation of it. So the next time you look at a flower, a seashell, or the stars in the night sky, remember this deep and beautiful question. Are you witnessing the universe's own mathematical artistry, a glimpse into a cosmic code that predates humanity? Or are you seeing the reflection of the human mind's greatest invention, a powerful language that allows us to tell the story of the universe? Perhaps the answer is that you are seeing both at the same time, a dance between the patterns of the cosmos and the elegant logic of the human mind. The question itself is what keeps us curious, pushing us to explore the world around us and our own place within it. If this journey into the nature of reality sparked your curiosity, be sure to explore more of our videos here on Curiosity Repo.